Hello viewers, welcome once again to Fame Global Academy, where we learn beyond boundaries. And I'm your favorite physics teacher, Fred Mark. In this section, we're going to be encouraging and teaching students on how to answer JAMB question, preparing the student for JAMB question. At the end of this program, you are coming out in flying colors. Okay, I'm starting with physics, and I'm going to be doing some questions and the techniques to answer these questions. Okay, now the first question on the board, we are having question 1 says, if a metal wire 4-meter long and a cross-sectional area of 0.8 millimeter square, take note, 0.8 millimeter square, has a resistance of 6 ohms. Find the resistivity of the wire. Find the resistivity of the wire. Now, you should be cognizant of answering JAMB questions. You don't spend more than 1 minute in a particular question. But for the sake of our learning, we're going to be going more than 1 second. But as you continue, you build up your speed. The first thing is to know the fundamental of these questions. Now, first of all, given. What am I giving? Now, the length of the wire, 4 meter. What else is given? Area is 0.8 millimeter square. Now, resistivity, I said for those of us, and at this stage, you should know that your SI unit is very, very paramount. Now, the SI unit for resistivity is in ohms meters. Ohms meter, that is the SI unit for resistivity. So if I am given any questions in millimeter, I have to convert it to meters. So converting to meters becomes 0.8 times 10 to the power minus 6 meters square. Because it's in millimeter square. It's supposed to be 0.10 to power minus 3, but because it's square, it's to power minus 6. Now let's continue. What else is still given? Resistance. 6 ohms. And I'm asked to find resistivity, which is rho, is unknown. Now this is the symbol for resistivity, rho. Now R is equals to rho L over A. This is our formula. R is equals to rho L over A, where your R is representing the resistance in a resistor, L is your length, A is your area. But I'm asked to find resistivity. So RL is equals to RA. Then rho becomes RA all over L. RA all over L. Now, all I need to do now is to impute these parameters into this formula. Rho becomes RA all over L. Rho, R is 6 times, what's our area is 0.8 times 10 to the power minus 6 all over 4. 6 times 0.8 to the power minus 6 divided by 4. So if you do that, you're having 1.2 times 10 raised to the power minus 6 ohms meters. If I multiply 6 times 0.2 to the power minus 6 divided by 4, I will have 1.2 times 10 to the power minus 6 in ohms meter. The ohms meter is the SI unit for resistivity. Remember, you have just 1 minute to answer this question. So you build your speed as very fast as possible. First and foremost, you write out what I'm asked to look for. Now I'm asked to look for resistivity, is unknown. I'm given resistance at 6 ohms. I'm given area at 0.8 millimeter square. If I convert to meters, I'm having 0.8 times 10 to the power minus 6 because of the square. And then the length of the wire is 4 meters. Now imputing it, the resistance of a resistivity, R is equals to rho L over A. R is equals to resistivity times length all over area. I'm using the word rho because that's the symbol. So rho L, if I bring it out, making cross multiplying, rho L is equals to RA. So rho becomes RA over L. Resistivity becomes resistance times area all over length. Now, impute this one into the formula. So wherever I have rho, 6. 6 times 10 to the power minus 6, which is your area, all over 4. So rho becomes 1.2 times 10 to the power minus 6 ohms meters. Now this is the answer to this very question that says if a metal wire 4 meter long and a cross-sectional area of 0.8 millimeters square has a resistance of 6 ohms, find the resistivity of the wire. Resistivity of the wire is now 1.2 to the power minus 6 ohms meters. Your SI unit is very important. Your conversion very important. You should know how to convert. Converting from millimeters to meters. And remember, millimeters to meter. Remember, it is in millimeters square, so I have to convert it to meter square. So millimeters to meters is supposed to be 10 to the power minus 3, but because it's square, 10 to the power minus 6. Okay, I believe this is clear. Go over to question 2. Question 2. Question 2. Okay. 21,000 of heat. 21,000 of heat is required to raise the temperature of a certain mass of water from 0 degrees Celsius to 80 degrees Celsius. Calculate the mass of the water bracket specific heat capacity is 4.2 joules gram per Kelvin. Okay, I read the question again. Question 2 now says 21,000 of heat is required to raise the temperature of a certain mass of water from 0 degrees Celsius to 80 degrees Celsius. Calculate the mass of the water. In bracket, the specific capacity of water is now 4.2 joules per gram per Kelvin. That is now the specific heat capacity of the water, which is 4.2 joules per gram per Kelvin. Remember, the specific capacity of the water, if it's not given, you should look for. But in most cases, you are expected that it must give to you the specific capacity of any, could be of iron, it could be of steel, it could be of water, and the case may be. But it will be given. It is standard, it is constant, but it will be given. Okay, now let's go. First and foremost, what am I asked to look for? What am I giving? Now, heat is equals to 21,000. Okay, the SHC, which is specific heat capacity, is 4.2 joules gram per Kelvin. Okay, what else is given? Temperature, theta. Temperature, you have the temperature is ranging from 0 degrees Celsius to 80 degrees Celsius. So the thing I will do now is change in temperature. Delta T, delta theta means change in temperature, which is 80 degree minus 0 degrees Celsius. Change in temperature means theta 2 minus theta 1, where your theta 1 is 0 degree, your theta 2 is 80 degrees Celsius. So your delta T is means change in temperature, which is delta theta 2 minus theta 1 to get a temperature. So delta T is what? 80 degrees Celsius. Now these and these are given. I come again before we start serving. I said 21,000 of heat is required to raise the temperature of a certain mass of water from 0 degrees Celsius to 80 degrees Celsius. Calculate the mass of the water. The specific heat capacity of the water is given as 4.2 joules per gram per Kelvin. Now, so write out the parameters to know what I'm looking for and what I am given. I'm asked to look for mass, is unknown. So now, H, which is the heat is 21,000. SHC is representing specific heat capacity, is given as 4.2. And then delta T, which is the change in temperature, is theta 1. Delta T means change in temperature, which is theta 2 minus theta 1. Your theta 1 is 0 degrees Celsius and your theta 2 is 80 degrees Celsius. So delta T, which is change in temperature, is theta 2 minus theta 1 to get 80. So 80 minus 0, you are having 80. And I'm asked to find M, which is the mass of the water. Okay, using the formula, H is equals to mc delta T. Heat capacity. H is representing heat capacity. The formula for heat capacity is H is equals to mc delta T. H is equals to mc delta T using the formula. Using this formula above. So H, which is heat capacity, is equals to mc delta T. The M is representing the mass which we are asked to look for. Delta T is the change in temperature. Then H is the word heat capacity. And then C is representing the specific heat capacity. C is representing specific heat capacity. Is the symbol for specific heat capacity. Now, what do I do now? Is either I put my parameters into this or make my M immediately the subject of formula. So I have M C delta T is equals to H, the same thing. And so if I divide both sides by C delta T, divide both sides by C delta T, C delta T. So this goes, I have M is equals to H over C delta theta. M now is what I'm looking for. H is 21,000 all over 4.2, which is the specific capacity of water, times 80. 80 is now the change in temperature. Change in temperature. I come again. You are asked to find the mass of the water. Mass of the water, given the specific capacity of water as 4.2. The first thing to do is, what is the formula for heat capacity? The formula for heat capacity is H is equals to mc delta T. mc delta theta. Delta is change in temperature. Now, using the formula above, and I want to make my M the subject of formula. What do? I divide both sides by mc theta so that M can stand on its own. If I do that, I'm having M is equals to H over C delta theta. This will definitely cancel this. Now, having done that, I will now impute this into the formula. I impute this into the formula. M is equals to 21,000 all over 4.2 times 80. Okay, let's continue. M So if I have 21,000, if I multiply 40 4.2 times 8, I will have 336. 336. 336. And if I now divide 21,000 by 336, I'm having 62.5 grams. 62.5 grams. Because mass is in, okay, let me say kilogram. Because mass is gram. Gram. With 62.5 kilogram. That's the mass of the water. The mass of the water. Kilogram per dm cubed. Okay. Now, remember, I said you have just 1 minute to answer this question. So you do try as fast as at the in your screen, in your those of us who are writing JAMB, you know that JAMB is CBT, is your system. By the system there, you should see your small calculator, which we call the market woman calculator, where all these things are there. But the science, the it's not scientific calculator, it's just a normal calculator where you have just division, addition, subtraction, and multiplication, and it ends there. So you, if when it comes to angles, you become you there are some angles that you have to put at the back of your mind. So when you see some angles like what is sine 45, what is sine sine 45, sine 90, cos 45, cos 90, those ones should be in your memory. So because there is no space for it in your calculator in the exam hall, so you should be conversant with those ones. But those ones, these ones that are easy to calculate, your positive, your multiplication, addition, subtraction, division, is on the screen there. You just click. If you want to add, you click. If you want to subtract, you click. If you want to divide, you click. But once it's beyond that, they expect you to know that this and this is this. Questions beyond what scientific can calculate will not be given to you. So there are things you should just be conversant with. Okay, so if I divide 21,000 divided by 326, I have 62.4 kilograms. That is the mass of the water. So, but know as many formulas as possible. Know as many formulas. People will say physics questions are technical, yes, because there are a lot of formulas, but one linked to the other. But as you keep doing it each day, you become used to these formulas. Just all you need to do is just to apply them. Just know how to apply and know your XI unit and your conversion. See, this is as simple as pie. So go on to question 3.